Good afternoon, everyone. Thank you for coming along. My name's Robin Moffatt, and I work for Confluent. So today I'm going to talk about Apache Kafka and its role in modern data architectures. To start with, I've got 4 questions for audience participation, and then that's it. You can go back to sleep. But to start with, hands up who's using Kafka currently? That's cool. Keep your hands up if you're using Kafka Connect. OK, Kafka Streams and KSQL. OK, maybe we can try and fix that today. So we're going to talk about what Kafka is. We're going to go into kind of the architectural reasoning around it, talk about some of the problems that it solves. We'll talk a little bit about under the covers as well, but it's not like a deep dive into Kafka itself, more of an architectural positioning and understanding of it. So I'm a developer advocate at Confluent. Before joining Confluent a year and a half ago, I was a consultant. Before that, I was working full-time in a retail chain, building data warehouses, building data lakes, data platforms. I've been working in data analytics for best part of 20 years now. So there's some interesting patterns which come and go and things coming around again. And so it's interesting seeing that through the lens of Kafka and the event-driven architectures. I like tweeting a lot. You can tweet me at @I'mOff. Tell me if you like the talk, if it was useful or not. The slides are on Speaker Deck. Obviously, the recording will be online afterwards as well. So lots of people use Kafka. Lots of people have heard of Kafka. And Kafka is different things to different people. So to start off with, I want to explore what Kafka actually is. So what Kafka actually is a streaming platform. Not everyone understands it that way. Some people think of Kafka as it's a message bus, or it's a pub sub tool, or it's a pipe for ingesting data. And it's all of those things, but more. And if there's probably one thing I'd like you to take away from the talk today, is that Kafka is actually a platform on which you can build your applications and your data structures within your organization. It's not just a bit of tooling to kind of like do a little bit over here. It's not just a message queue. It's actually a platform. And understanding its potential as a platform then lets you make much stronger architectural decisions around it. So it's a streaming platform. But why do we need a streaming platform? What's it actually going to do for us? And there's several key elements to what a streaming platform is. I'm going to talk about kind of more of a definition of it in a moment. But to start with, let's kind of like look at why we actually want it. And one of the reasons you want a streaming platform is its ability to decouple your applications and what you've built. Because not always when you set out building something are you going to do it right the first time. So my background, as I say, is in data warehousing. It's in analytics, kind of what then became big data. And one of the things that we have here is this pattern in which people build things. So back in the beginning, back in the old days, like 40 years ago, 30 years ago, people would have transactional systems, they're OLTP systems, if you kind of recognize that term. And within there, you had your transactional data. Here's the stuff that's happening in my business. Our sales are being recorded, and we want to know what's happening in our business. So we take that data, and we take it from our sales transactional database, and we stick it over in what we then call a data warehouse. We copy it from one place to another. But obviously, there's more than just sales that happen in an organization. There's things like the stock that we sell. So we have inventory. So we say, well, that's obviously going to be managed by a separate system. So we'll take that, and we'll also go and move it into our data warehouse. So now we have copies of our normalized structures of our transactional data, which is great for getting data in, but sucks for getting it out. So we say, well, let's do some transformation on it. Let's get it into a denormalized structure that's going to be performant for reading that data out. Let's enrich the data. Let's denormalize it and conform the dimensions, all that kind of good stuff that you do in data warehousing. So whether we do transform and load or load and transform, it's the same kind of principle, taking a bunch of data from places and shoving it somewhere else. And then someone comes along and says, well, actually, data warehouses, they're somewhat passé. What you actually need is a data lake. So what we can do is we can say, well, we'll take your data warehouse and we'll copy chunks of it, and we'll go and stick it in a data lake for you. Or we could get really fancy, and we'll actually reroute your transactional systems, and they can go and dump data in a data lake. But of course, you still need to do those batch transformations. You've still got data that you've chucked into it that you need to then pick up and process again. So one of the aspects of that is this idea of having to land it somewhere and then picking up and processing it again. So by using batch-driven processes to get the data out of those transactional systems, batch-driven processes to take that data once it's landed and process it into a form we can use it, it's slow. It introduces latency by design. We're consciously deciding when we have this data, we're going to wait a while before we process it. And that's not a great way to do things. So we need to be able to evolve that. We want to get away from the idea of batch. We also want to be able to get away from this idea of point-to-point connections of data. There's other things, though, that are driving why we may want to use a streaming platform. The world has changed around us in terms of data and technologies. So we have things like the Internet of Things. We have simply greater volumes by orders of magnitude of data more. It's not just a few transactions from a point-of-sale system coming in once a night. There's so much more data coming in. So we have to have different ways of coping with it. We have microservices. We have, maybe they're using message queues, maybe they're using databases, maybe they're using Kafka, hopefully, to communicate. But we have data sat in lots of different places now. It's not just in one transactional database, or hopefully not. We also have mobile devices. Again, lots more data. We then have things like event time that we need to reason about when we're processing the data. And then we have machine learning with the scary Terminator figure. Whether we're wanting data sets with which to train it, or take those models and apply it to our streams of data, how we work with data has fundamentally changed from what we used to do. And then we have lots more technologies. And this is generally a good thing. Certainly for all of us as technologists, it's fun. There's lots of spicy things to go and play with. It's great. But it means we have to have better ways of being able to integrate them and be able to work with them. You can no longer say, well, we have vendor X, and all their systems will play together to a greater or lesser degree. It's going to be lots and lots of different types. There'll be proprietary software, open source software. There's lots of different ways where we have data. So we need another way to actually bring it all together. And if we don't think about it carefully, if we don't actually build out our systems with this in mind, then we end up with this. This is the famous spaghetti diagram that you'll have seen if you've been to Kafka talks before. And it shows at a high level the kind of systems that organizations end up with. No one sets out to build it, hopefully. People end up with this. They start off with databases at the center where you store your state for your applications. And you have multiple databases because you have multiple systems. And then that needs to go to a data warehouse, and you need a bit of real time somewhere, so you bolt something on top to do that. And then you have some message queues, and then you have some search replicas and graph databases, and this proliferation of different systems, all of them tightly coupled together, all of them point-to-point fed, and it doesn't scale. You can't scale it out to cope with greater volumes of data. You can't scale it to cope with greater throughput and lower latency requirements. And you can't change different pieces within it because you're too scared to touch it. You know that if you change that one piece there, it's connected to 5 others, and you're not quite sure what's going to happen. Or you do, but it's going to take 6 months of change release processes and testing. So moving away from this to a streaming platform, to a way of decoupling what you build, is a sensible way to look at things. So Kafka gives you this idea of a streaming platform, a way to enable all of your different systems to communicate with each other, but in a loosely coupled way. So Kafka is a distributed system, so it scales, it can cope with the throughput, it can cope with the big data, but it's also about connecting systems and connecting the events that flow between them. So Kafka is a streaming platform. So let's think more about what we actually mean by a streaming platform. We've been through some of the reasons of why we might want to think about them being useful. So there are 3 different ways of looking at what a streaming platform is, 3 different lenses. So the first of these is messaging done right. The second is scalable streaming data pipelines. And the third is a foundation for stream processing. So when we say messaging done right, messaging has been around for many years, and you get lots of different messaging tools, and they all do kind of the same thing with different kind of bells and whistles, but they all have the same kind of problems. And Kafka is not just another messaging tool. Kafka is highly scalable. It's a distributed system. So you can scale it out as you need to. And sometimes that alone is why people adopt Kafka. And that's then why those people think of Kafka as just, well, it's just a message queue. Because it was better than the other ones we're using, it's just a message queue. It is, but it's a lot more than that. So Kafka also persists your data. You can tell Kafka to keep a particular topic for 1 minute, 1 week. You can tell it to keep it forever, depending on how long you need that business data for. And Kafka has built-in real-time processing. You can do stream processing with Kafka itself. You don't need additional tool sets to do that. So you can process the data as it passes through. So it's a lot more than just a messaging system. Kafka also enables you to build these scalable streaming data pipelines. So you can use it for integrating data from throughout your business. You can hook it up to databases, to message queues, to flat files, to wherever you have data sitting, you can stream it into Kafka. Kafka acts as that integration point, as the applying back pressure, the decoupling between those systems, because then it can also stream data from Kafka down to other targets, down to HDFS, down to S3, to Snowflake, to BigQuery, wherever you want to stream data to, you can do that using Kafka. So Kafka has an API called Kafka Connect that lets you do this. It's just a configuration file that you set up. You point it where I want data from, you point it to the Kafka topic, you point to a Kafka topic at where you want data to go to, and it streams it on. And the third aspect of a streaming platform is a foundation for stream processing. So Apache Kafka has the Kafka Streams API. It's a Java library that you include in your application, and then you can do stream processing in your application. You can take a Kafka topic and simply filter the messages for particular ones that you're interested in. You can join streams of data. You can aggregate streams of data within your application using the Kafka Streams API. And you can also use KSQL, which is a SQL layer on top of Kafka Streams. I'm going to talk about those more later. So all of this gives you the streaming platform, a way of integrating your applications, your databases, your Hadoops, your message queues, wherever you have data in your organization, Kafka can sit at the heart of it. And the key things are, it makes the way you work with data event-driven, it's scalable, and it's decoupled. So I said in event-driven, I've mentioned events a few times, and events are super important. Events are the lowest granularity of data, and events are all around us. And events are amazing things, because an event is both a notification and a transfer of state. So it sounds a little bit abstract and weird, but as I say, I've worked with data for lots and lots and lots of years, and events make a lot of sense. Even if you're thinking in terms of like big data and pools of data in a data lake, events are still actually at the heart of it. And we're going to build on that through this. So events are all around us. All of our data is actually an event stream. Okay? So whether we're talking about business events, so a customer interacts with us, a customer has a particular experience with our business, that's an event. How we record it, which platform, which technology we use, that's an implementation detail. It's an event that started with. Something happened and we know something about that person. Something was bought, a product was bought. There's your event. Something was bought. What was bought? Well, there's your state. We have events coming from technology systems, from sensors, from IoT devices, from our applications. They're writing logs or they're sending their logs, their events directly to Kafka. Something happened in the application. It's an event. And then we have databases. So this is the one which people kind of like start to screw their faces up and look a little bit puzzled at, that databases are a stream of events. So I want to explain why. And as I say, my background's analytics, my background's databases, and actually, if you bear with me on this, it makes a huge amount of sense. So you go to a database and you run a query. You do a select star against a table. It looks and it feels and it smells like a table. It looks like a static lump of data. But under the covers, it's actually a stream of events. So here's an example. You've got a bank. They have a database. They have a table which holds balances. So we can say for our account balance, our accounts 1, 2, 3, 4, 5, the balance 50 euros. But why is there 50 euros in the account? Well, because someone deposited money. At a particular time, they deposited 50 euros. And then they deposit some more, and now our balance has changed. They deposited 25 euros, now our balance is 75. And then we spend some money, and now we have a balance of 15 euros. So what this gives us is a stream of events over here on the left, and a table on the right. The stream is our event stream, and from that stream, you can reconstruct your state. The table is the state of a given key at a point in time. So the key thing here is, from that event stream, you can rebuild that state. From the state, any modifications to that state are actually events that go onto the event stream. So this is why we call it the stream table duality. It works both ways. And there's two key things here. That stream of events is an event log. Kafka is an event log, an immutable event log. But it's also a database transaction log. Okay, if there are any DBAs in the room, you'll recognize that's your transaction log that you love and protect and worship and hope you don't lose when you need to restore your backups, because that's what you roll forward to restore the state of your database. So there's this great quotation from Pat Helland. He says, the truth is the log. The log's all you actually need. The database is a cache of a subset of the log. If you have the log, you can rebuild your state. And where this comes into Kafka is that we say, well, the events are what matter. The events are what make up this immutable log, and then we can rebuild state wherever we want. That's just something we'll kind of figure out afterwards. We want the events. They're what drive everything. Maybe we want to build the state into a database, but we can also then take that event log and build it into a search replica or a NoSQL store if they're better places to persist the state for what we're actually wanting to build. So it's moving away from this idea of you have to have a database, and then we'll figure out how to hook stuff up to it. You need your events, and from your events, you can build your state wherever you want it. OK, so let's now have a little bit of a look at what Kafka is under the covers. This is a very much kind of a quick look at it. It's not a deep dive. So Kafka itself is a streaming platform. As I said, it's built around the log. It's a distributed commit log, and it has some interesting APIs around it. So we have the producer and consumer APIs. There's client libraries for all the kind of common languages. So from your application, you can produce messages to Kafka. You can consume messages from Kafka. You also have connectors. Kafka Connect, I mentioned a moment ago, it's part of Apache Kafka, and it gives you configuration files for doing streaming integration between your source and target systems. There's a Java API if you want to write your own connector, but there's tons of connectors pre-built out there for you. And then there's a streaming engine. The Kafka Streams API, part of Apache Kafka, that lets you do stream processing within your Java applications. So the log itself, it's a very simple idea. All we do is we append events to it. It's immutable. You can't go back and change part of it. But that gives it some very, very strong powers. Because by knowing that it's immutable, by knowing that nothing's changed, we can actually use it to replay state. So messages get added to the end of it, and because it's persisted, and we can define that persistence per topic, because it's persisted, you can have multiple different people reading from it. This is not, again, this is like, it's so different from a messaging queue where you read a message and it's gone. In Kafka, you read a message, okay, all that happens is your application's offset gets updated. I got to here, someone else is reading, they got to there, that's fine. When I come back online, I'll keep on reading and get up to the end. So each application has its own offset in the log, and it just picks where it wants to read to. So it's a sequential access. You pick where you want to go in the log and scan through and read your data. The Kafka Connect API I've mentioned, you use streaming integration between other systems. So it works with pretty much every data source out there. There's some great community contributions as well. I was chatting to someone earlier who's written one for Telegram. You've got data sat in a Kafka topic. You want to stream it out to a Telegram bot to do notifications. That's brilliant. That's exactly what Kafka Connect's there for. Instead of writing your own bespoke code, which works great for that project, actually you say, well, what's useful is to say, well, we've got events on a Kafka topic. We're going to use those to drive something over here. And then you can do stream processing in Kafka. You can actually start to do that processing that you want to do on your topics within Kafka itself. And there's different ways of doing that stream processing. So there's KSQL. So KSQL is an open source project from Confluent. It builds on the Kafka Streams API, and it gives you a SQL interface to working with Kafka. So if anyone saw my talk yesterday, I did an example of it. It's recorded. It's online already, which is super cool. Thank you, Devoxx. And it actually lets you write SQL statements. Select star from a topic where condition is this. But more than just writing SQL statements to query your data, you can write stream processing applications in SQL. So you can say, I'm interested in looking at my syslog data that's in a Kafka topic. I want to filter it for a particular condition. And if this condition's met, go and write it somewhere else. That's a very common thing that you want to do. Filter your inbound streams of data. You can express it in a SQL statement. And that's a SQL code file that you then deploy onto your KSQL server in production. You don't have to wrap it in a ton of boilerplate and stuff like that. You just deploy that SQL file to your server. You can use it for doing streaming ETL. You can join between streams of events and facts and your reference information, your dimensions. As things are happening in your business, you can enrich those with information about them from elsewhere. And it's working on Kafka topics. That information could be coming from anywhere. It could be coming from a database. It could be coming from flat files, from a message queue. Wherever you have data, you can get it onto Kafka, and then you can join it to other things that are happening in your business. There's also Kafka Streams, the API. So depending on which you prefer, if you like writing Java, go write Java. It's great. If you want to write SQL or you can't write Java, then go use KSQL. It's also great. So that's a kind of a rapid look through the kind of things that Kafka is under the covers. And there's obviously a lot more resources out there for kind of understanding it in more depth. Now let's look at some of the problems, kind of like taking a step back a bit higher up architecturally. What are the kind of problems when we're building systems that Kafka solves for us? And the key thing when we're building systems is this idea of event-centric thinking. Think of data as events. Don't think of it as, I need to build something over here to do something, and I guess I get my data there. Which is difficult to do, because as developers, someone says, your job is to build that over there that does this thing. So let's say someone says, OK, we need to analyze what's happening on our website. We've got application logs coming in from the web server. We want to find out what's happening in terms of people viewing products. So the obvious thing to do is, well, let's take our logs from our web application and chuck them into Hadoop or S3 or somewhere like that. Okay, that's the obvious thing to do. But the problem is then, as well as viewing products on our website, people can view them on the mobile app. Or we open up the API and there's a third-party API. So now we have product view events coming from different places. And now we need to get those down into the kind of Hadoop place as well. The sensible way to approach this is to think of them as events. An event happened, someone viewed a product. Let's put that into Kafka. From Kafka, we can stream it down to Hadoop. So at this stage, it seems like we're over-engineering. Why are you bringing in Kafka? All you need to do is data from there to there. Get on with it. But you'll see how this actually builds and makes so much sense. Because as we add in our additional sources, now we simply point that source, doing whatever it's doing, at Kafka and say, OK, product view onto Kafka, please. We don't have to tell it where Hadoop is. We don't have to know anything about that downstream application. That downstream application just consumes its events from Kafka. Oh, a product view happened. A product view happened. Doesn't matter where it came from. If we don't use Kafka, and we say, oh, it's fine, we're good, we're just going to do point-to-point, we're going to chuck our data into Hadoop, that's fine. Someone comes along and says, well, it started off just being Hadoop, just being a data lake, didn't matter if it was too late and so whatever. Turns out, viewing products is quite an important event to a business. Not only do we want to analyze it as kind of like a long-term thing, what's the trends over time, doesn't matter if it's batch, doesn't matter if it takes a long time, it's just a report. Well, actually, a product view event, you can use that to drive a recommendation engine. You can use it to drive real-time security analysis. You can use it for monitoring what's happening on your site. And suddenly, latency kind of matters. So if we don't do that, now we have this horrible kind of crisscross of dependencies. So instead, we say, well, aha, now I feel smug. I built around a streaming platform. When an event happened, I emitted it to Kafka. Now my different applications, they have the data when they want it. My laggy doesn't matter if it's slow latency Hadoop thing. It keeps on getting the data when it needs it. But my real-time applications have access to those real-time events without having to do some even kind of worse, coupling them back to the original sources. Kafka also helps a much more simple level in terms of if systems go on and offline. We all know that things break, particularly as things become more distributed and cloud-based and networks go down and all the rest of it. This idea of saying, I have this here, I'm going to send data to that thing there, it's going to be fine. Or, well, maybe it won't be. Now I'm going to build in a bunch of retry code around each one to kind of cope with if things break or not. Instead, as something happens, put it into Kafka. Your consumer takes the data from Kafka. If either end goes offline, that's fine. The other one doesn't even know. Kafka acts as that kind of that back pressure, that buffering of your data. Also, Kafka, as I talked about before, enables you to work with different latency requirements in your data. You start off with this very common thing of, I just want a once-a-day batch extract of data. Don't talk to me about events. Once-a-day batch extract, I'm good. But then data is used in multiple places. Someone else comes along and says, I need this data in real time. I'm doing some real-time analysis, some fraud detection, something like that. I need that same data. It's like, well, OK, we've got the same data. We'll just take it from the first place. Well, that's no use because you get it once a day. I need it real time. So instead we say, well, OK, we'll hook you up to the source. At which point the source owner says, whoa, 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 why are you taking it twice? That's kind of like twice the hit on my system. That's twice the reads. I don't want that. So, OK, fine. We'll do a real-time feed into our new system, and we'll rewire the original one to take that feed up when it needs that once-a-day thing. You can see how it doesn't make sense retrofitting this kind of thing. The key thing here is an event happens, get it into Kafka. And then your different consumers, they can decide when they actually need to use that data. Batch once a day, the data's persisted in Kafka. It just goes and connects, reads from wherever in the log it got to. The other consumer, real-time read of the data. So Kafka also, because it persists data, lets you do really cool parallel running between different versions of code or even different technologies. So you can say at the moment we've got data coming in, we're reading it from Kafka. Maybe we're using it to score data using a machine learning model that we've got in our Streams application. And we've trained a new version of the model. We want to run it side by side. So we're going to take the new code, we're going to deploy it. It's going to read all of the existing data in Kafka and score it through, so we can kind of compare it to what was there before. But it's going to continue to read the live stream of data. Now we have two consumers of that same data side by side. We can say, well, does this make sense? Are they behaving themselves? If they are, we just switch off the first one. So it's a very nice kind of like seamless cutover. You don't have to kind of take copies of production and run it through this and then try and work out how do we do that switch over. And it's just the same pipe of data. We just hook up two different people. So now let's take a further step up and look at some of the patterns around how you can use those principles I've just talked about to actually build out different systems with Kafka. The key thing, as I've mentioned already, is this idea of forward-looking when you're building things. Not just I'm going to fix this thing today and I'm done, but actually how do I avoid ending up with that spaghetti picture that we saw earlier, 6 months, 6 years down the line. We want to avoid coupling things together. Point-to-point connections are horrible. They're just a legacy thing that you're going to kind of, hopefully if you've left your job and someone else is going to have to worry about, if you're still there, it'll come back to bite you. But tightly coupling things together is often a bad idea. So Kafka lets us avoid doing that. So very simple use of Kafka is simply taking data from a database or databases, streaming it through into a data lake. That's what tons of people do already. I guess if I did show of hands, there'd be people who are like, yeah, we do that. Because that's why Kafka's in the Hadoop distributions. It's a really good way of getting data from here down into Hadoop, or up into S3, or whichever one we're going to use. But this is a great example where we're starting off small with Kafka, but we're going to build on it because we're aware of what we could be doing. Because today we've got data sat in our database, our transactional system, downstream into the data lake. We're going to do our analytics on it down there. But of course, that's normalized data that's going down into the data lake. Generally, we're going to need to denormalize it or bring out our dimensions or whatever good stuff we do down there. Now we have batch happening over there. We've streamed it through real-time, lovely, down into the data lake. Now we wait, batch process, boring. Within the database, we've got different tables. We've got information about orders that are being placed. We've got information about customers who are placing those orders. Why do we wait until we've landed it down the other end to actually join those together? We can join those together as they pass through Kafka. So as your orders are being placed, these are your events, your facts, you can actually they enter Kafka. Every event that comes in, we do a lookup against the Kafka topic that holds information about the customers. That Kafka topic is maintained as a direct mirror of our customers in the database. So we're not doing lookups back to the database. We're doing lookups against that data that sits within Kafka. So then that populates another Kafka topic with enriched orders. Not just orders, but who placed the order, what was their address, and so on and so on. That can be then used to feed downstream to actually do useful things, drive operational dashboards, or down to our analytics. But because we're building on Kafka, when someone says, well, that database we got up there with the kind of like big hairy monolith sat on top of it, that's not always such a good idea. We're going to do the cool thing. We're going to do microservices. We're going to break it out. Now we have customers are sat in the database. Okay, relational databases, great place to store your really important data like customers. But our events, our orders being placed by the business, these now come from a microservice up there. So that microservice emits those order events into Kafka, same process. Could even be the same code if the schema stays the same. Order event comes in, join it to the customers, out downstream. If you imagine we did this bit here without Kafka in the middle, then it's like old school ETL. We've got a database. It's going to go through ETL and then down into there. Someone says, OK, we're doing microservices. Yay! My data, by the way, now it's up here. That ETL that we built, out the window. So being able to implement that microservice process now becomes a whole bunch more painful because you have to kind of like sticky tape some stuff on top of it to try and satisfy the existing requirements. So Kafka gives you this basis on which to build out your architectures and evolve them in a sensible way. But because we've got that data in Kafka about orders that are being placed that are serving a particular use, that it's driving a customer's orders dashboard in this case, because we've got that information in Kafka, we can use it to drive other things. We can say, well, we've also got a microservice that's responsible for notifying customers that their order's being received, or sending out shipments, or doing something that needs to know about an order event and the customer. So instead of saying, well, we've got customers over here, we've got order events up there, order events maybe tells this microservice that's going to do a lookup to the database over here. That's yucky. We've already got the data in Kafka. As the order event happened, it came into Kafka. We brought in the customer information and enriched it. We have a Kafka topic with enriched orders. So that drives our customer's dashboard. It can also drive directly that microservice. So it gives you a very good way to actually build these things out. So I've been talking about kind of through an analytics lens, but you can actually build out entire microservice architectures using Kafka as the backbone. Because Kafka persists the data, you can use it to actually build out this stuff. So my colleague, Ben Stopford, who I stole that diagram from, he's doing a talk on Friday about this kind of stuff in much more detail, so come along to that if you're interested. So Kafka gives us the ability to build new systems, kind of forward-looking and making sure that people can actually build on them in a sensible way. But it also lets us evolve existing systems. So I mentioned the idea there of moving from a database to a microservice. So where we have existing applications powered by a database, it doesn't have to be a case of, well, we'll have to rip and replace it and then start again with Kafka. Kafka supports integration with databases. If you came to my talk yesterday, you'll have seen the CDC demo. As something changes in the database, regardless of what changed it, that streams into Kafka. So then you can start to build out your new applications that may be chipping away at that existing functionality in your existing application, but it means that that existing application keeps on working. So you can build in more and more applications whilst retaining the existing one. So this slide that I showed earlier about batch as latency built in by design, I wrote this, I was kind of like, well, that's obviously a bad thing. I'm going to find a silly dog photo and it'll make people laugh. And someone came to a talk that I did with this slide a few months ago, and they saw it and they tweeted at me. They said, you say that like latency is a synonym for evil. And I thought that was really interesting because I just made that assumption. I've been doing this event stuff for long enough that latency bad. And they were like, well, is it? And it was really interesting because it got me thinking, is latency bad? Does latency matter? And it actually comes back to the events. It's not about this thing you're building over here, I don't need that data yet. It's about the events. Something happened. So I've got an example. So I travel quite a lot at conferences and stuff, and you go to the airport and you buy something, you buy a packet of crisps or something for a lot of money, and you get a push notification to your phone. Okay, that's useful. I have no idea, maybe someone can actually tell me afterwards, I have no idea how Amex's system is built, but based on their other systems, I'm guessing it's just tacked on top of their transaction handling. I get a push notification to my phone, that's useful, okay. And then my airline tells me which gate my flight's departing from, again, based on their other systems I've interacted with, guessing it's just tacked on, I don't know, but guessing. Then I land in the country I'm going to, and my other bank sends me a notification. They say, oh, looks like you've landed in a different country. Welcome, by the way, here's the flag of the country, and here's the current exchange rate. This is kind of useful. And then I buy a train ticket from the airport into town. They say, OK, you've just bought something, kind of like Amex did, but they said, well, here's the conversion into your home currency. And because it was at a train station, here's the silly emoji of a train. This is actually taking events as they happen and doing useful things with them. They know that I've landed in a country, so they send me a push notification. They know what the current exchange rate is, so they're monitoring exchange rates as events. They can bring these things together. They even know about the places that you buy tickets from and what emoji to put with them. These are events that they're bringing together. So it's not just push notifications, it's actually the entire experience for the customer. I log onto the application, it tells me exactly what I've spent there and then. It tells me what my balance is. It was updated a few seconds ago. Like, as I say, I travel a lot, it's an absolute pain. I have to wait till next week to find out what my credit card's going to charge me in terms of the conversion rate. My bank that's actually built around events can tell me what the charge is now, or give me an estimate of what it is now. And that's the difference. If you set out building systems just to do this thing, you're locked into that idea of, well, where's this lump of data come from? But actually events are all around us, and the idea of getting events into your streaming platform, into Kafka, you then have the possibility of doing whatever you want to with those events. So build around the events, not just the idea of latency of a particular target system that you have in mind, because you never know what's going to come next. You never know who else needs to use that data. Okay, so let's bring this all back to analytics in Kafka, which is my sweet spot. I've done analytics for years. I love Kafka. It's kind of an obvious thing to do with them. So in analytics and data warehousing, there's this idea of one version of the truth. Okay, and Gartner characterized this as basically as mode 1 IT. This idea of you have a bunch of systems, they're doing stuff, transactional systems. We will get that into our central data warehouse. And it'll be glorious because we will denormalize everything. We will conform all our dimensions. There'll be uniform KPI definitions. It'll be marvelous. Angels will sing. Unicorns will leap everywhere. But in practice, you end up with these skunkwork projects. You end up with people saying, well, your one version of the truth is lovely, but it's never delivered. We got kind of like this a year ago, and we're still waiting for all of that. We've got a business to run. We're just going to do the pragmatical approach, and this is crudely characterizing the mode 2 approach, which is get stuff done, in other words. So I'm going to spin up EC2, I'm going to dump my data in there, I'm going to get someone to write a Spark job, I'm going to chuck it into Redshift, I'm going to do whatever I need to do to get my job done with the data. And actually, I'm not interested in you guys saying, well, and girls, you've got too many connections going along, and it's data, you've got technical debt and things like that. That doesn't get my job done for me. So this is where Kafka comes in. It gives you a pragmatic approach to actually building your systems around data. So as we kind of like talked about again and again, Kafka gives you this ability to decouple things, to share the data, to process the data. So you can say, well, yes, we're going to take our data from our source systems. Yes, we're going to conform dimensions because that's a fundamentally important thing to do for consistent reporting. And we're going to put that in one version of truth. But we're going to acknowledge that people are also going to have their own little skunkwork projects, and that's absolutely fine too. And we're going to enable that using Kafka. So as events happen, you kind of spot the pattern here, as events happen, you get them into Kafka. And then the data's there for anyone who wants to use it with the appropriate security privileges. So we can build out our traditional mode 1, one version of the truth type stuff because we have the data to use. But we can do better than that. We can actually, as we're enriching our data, within Kafka probably, or downstream if you want to, that enriched data, that cleansed data, all those kind of like tricky little sharp edges when it comes to actually doing these projects, not just reading Hacker News, all those like awkward things we do to the data and we put it back on to Kafka. So now those other teams that want to do their own little side projects with the data, they can do that. They've got access to the source data. They've also got access to the enriched data. So hopefully, the good data will kind of like filter down, and you end up with fewer arguments over what does this KPI mean, and I thought margin was this, oh, I thought margin was that. So you can actually do that using Kafka, but Kafka's not just about analytics. One of the most difficult things I've found in IT in general is you have developers building transactional systems, and then you have data warehouse and ETL people doing their own kind of thing, and it's like never the twain shall meet. But actually, data is what unifies our organizations. So it's not just about enabling analytical systems with Kafka. It's about enabling the entire organization. So you have your transactional systems. They can use Kafka as their interchange of messages between them. That data that you've got in Kafka, it can drive your analytical systems like I've described, but it can also populate your search replicas. It can feed your graph databases. It can feed your NoSQL stores. Wherever you need the data, Kafka can act as that interchange for you. So here I'm talking at a very high level. Okay, I've got one great big Kafka logo in the center of that. In practice, this is a very logical high-level view. In practice, you have different Kafka clusters, you have different areas of processing. Some of the processing is done by teams themselves. It doesn't have to be done in Kafka. So this is not just like an ESB with a new label. There are some fundamentally different reasons around it. So processing can be done where you want to. The data's there in a decoupled way, and it enables you to actually build out things in a sensible way that can evolve in the future. So everything I've talked about here, it's part of Confluent Open Source, so a distribution of Apache Kafka. There's some super important things in there. The schema registry. I like submitting conference talks. I keep submitting a talk about schemas. No one's interested. It seems like it's too boring. It's one of these things like taking your vitamins. If you don't do it, you'll get sick later on. If you don't care about your schemas, when you're building out your data pipelines, your applications, it's going to hurt later on. But at the beginning, I was like, schemas, yeah, we'll just use like CSV or JSON. So schemas really, really matter. Schema registry is part of Confluent Open Source. KSQL, that I mentioned, also part of Confluent Open Source. There's connectors and latest version of Apache Kafka. So there's Docker images, there's RPMs, and so on. You can go and play with that. If you're interested in hearing more, There's a bunch of books you can get off our website, some really, really solid ones. Scan the QR code there, it'll take you to it. I'd be delighted if you rate the session. The feedback is really, really useful. And if you want to hear more, there are more talks from our colleagues, Tony Stubbs and Ben Stopford, later this week. Download Confluent there. If you're interested in Kafka, on the Slack group here, you sign up on the Slack link there. There's like 7,000 people talking about Kafka and Confluent Platform, different channels for different aspects of it. It's really good. And you'll find me on there at @I'mOff. You'll find me on Twitter at @I'mOff. Or drop me an email if you have any questions. I'll do my best to help you out. So with that, thank you very much for your time. And I have one request. I'm practicing my speaker selfies. It's really lame, but I'm going to try it again. So if everyone would wake up and give me a thumbs up or something like that, we're going to try and do it again. Thank you very much for your time.